All right. Hello, everyone. So today we are going to go over the notes we took for our exponent properties. But before we get into the properties, let's just remind ourselves what an exponent is. So an exponent is going to be if you have a situation like this. This guy is going to be our exponent. So let's write that. This is our exponent. And this is going to be our base, or our base number. So please notice that this number is bigger than this number. We have our 2 down here, and it is physically bigger than our 3. So whenever we write an exponent, it needs to be small and towards the top of our number, so that we can clearly see that 1 is a base and 1 is an exponent. Alrighty, so what does that exponent do? Well, it's going to tell us how many times we're multiplying our base by itself. So we're going to take our 2 here, since that's our base, and we're going to multiply it by itself 3 times. So that is what our exponent is doing. It is not 2 times 3. That is not what we're doing. We have 2 times itself 3 times. So we have 3 2's here. So when we do that, when we have 2 times 2 times 2, our answer should end up being 8. Okay, so like if we had 5 to the 2nd power, that's going to be the same as 5 times 5, because we have 5 2 times. There are 2 5's here. So it's not the same thing as 2 times 5. It's 5 times 5. So our answer would be 25 here. But not every time we see these, we're going to have a number as the base. Sometimes we'll have a variable, like x. So let's say we had x to the 4th power. That would be the same thing as x times x times x times x. So we would have 4 x's here. That is x times itself 4 times. Alrighty. So when we look at these, we're going to call this, like this small form, this is our condensed form. When we stretch it out like this and we show every piece, that is going to be our expanded form. Because we stretched it out and we spread it so that we could see every piece instead of just squishing it all together like our condensed form. Okay, so that's just a refresher on what an exponent is and what it does. So let's get into the properties that they have. We have 6 today, and we're going to go through each one. We're going to start with our examples with these ones because it's a little bit easier to see how they work that way. So let's go to the inside of our notes, and we'll start at the very top here. Okay, with example number 1. Okay, so this is going to be our product rule or product property. This will be the very first one that we have. So let's take a look at an example for that. We have x's here. We have an x to the 5th and an x to the 7th. Basically how you solve these is you want to expand it out first and then see what you can do with it. So we got x to the 5th power. So let's do x times x times x times x times x. Okay, that is that first bit. We have 5 x's here. Okay, then that's going to be times 7 more x's. So we're going to put those over here. We got 1, 2, 3, 4, 5, 6, 7. All right. Well, now we just have a bunch of x's in a row. Okay, well, that's the expanded form. So let's squash that back down again. How many x's do we have now? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our answer would be x to the 12th. Now, what happened between this 5 and 7 to get 12? What did we do with those two things? Well, we basically just added them together. If we have 5 x's that are being multiplied by each other, and then multiply that by 7 more x's, well, that's just going to be 12 x's altogether. So our shortcut for this, or our rule, will be x to the m, which is some number, and n, which is some number. We'll have x to the m plus n. That is our rule. So basically, if we see something that looks like this, we can automatically say, okay, my answer is just going to be the base, and its exponents will be added together, just like we did for this question here. We just took our exponents and we added those together to get our answer. So let's do that again for the second example. We got g2 times g to the second times g to the fourth power. Okay, well, using what we just did, we could just take our base, g, and then have our exponents added together. So we got 2 plus 4. Well, that's the same thing as g to the sixth power, because all we had to do was add together our exponents. All right, let's try the next one. We have d, and then that's will be multiplied by d to the eighth power. Okay, something to look out for. If you have a variable that doesn't have a visible exponent, your exponent is just going to be 1. Just like we have an invisible 1 out front, we also have 1 as an exponent. All right, so let's use that rule. We had our base d, and then our exponent would be our two given exponents added together. So that'd be 1 plus 8. Well, that's just d to the ninth power. And that would be our answer. So that's basically the product property. That's the first one we have. Okay, so let's move on to the next one. That is going to be the power of a power property. Okay, so those ones are going to look like this. Once again, I'm just going to start out by expanding this. So let's see, we have x to the second power, and then we put that to the third power. So what we could do is just take everything on the inside of this and just do 3 copies of that. So we got x squared times x squared times x squared. Okay, cool. Well, we could expand this even further because we got x squared, so we could just turn that into x times x. And then this is the same thing. We got x times x, and then again, x times x. Cool. Well, now this has expanded as far as we can. So how many x's do we have? We got 1, 2, 3, 4, 5, 6. So our answer should be x to the sixth power. Okay, so let's look again. How did we get from what we had to our answer? We had a 2 and a 3, so what operation happened between those to get 6? We multiplied them. 2 times 3 will give us 6. So that is going to be our rule for our power of a power property. If you have your base and you have an exponent on the inside, an exponent on the outside, you are going to multiply these two to get your answer. So our answer is going to have our base, and that's going to be to the m times n. And we're going to use that rule to do the rest of these. So we got number 2. Okay, so we got f to the 7th, and that's to the 4th power. Okay, well, we know that our rule is going to be the base to our inside exponent, which was 7, times our outside exponent, which was 4. So that's going to be f to the 28th, because 7 times 4 is 28. Okay, cool. Let's do the next one. Number 3, we have c to the 5th, and that's to the 2nd power. Okay, so we know we're going to start with our base, and then we're going to have our inside exponent, if we could read that, there we go, times our outside exponent, which is 2. So that's going to be c to the 5 times 2, that's 10. So c to the 10th power will be our answer for that one. That is our power of a power rule, or property. All right, let's do the next one. That is going to be the power of a product. Okay, power of a product. So that is going to look like this. All right, well, let's do the same thing we've been doing for the other ones and just expand it. So we're going to take everything on the inside and multiply by itself 3 times. So we got xy times xy times xy. Okay, cool. Well, we could expand that a little bit further. So we got x times y times x times y times x times y. All right, that's expanded as far as we can go. So what do we have? I see we have 1, 2, 3 x's. Okay, so that's x to the 3rd. And we have 1, 2, 3 y's. So that's y to the 3rd. So for our rule, looks like basically we're just distributing this exponent to both of the variables that are inside of your parentheses. So let's make that our rule. If we start out with our bases, which are x and y, we're going to end up with x with a distributed m, so that'll be to the m power, and then y to the m power 2, because we just got to take that m and distribute that exponent to both of our variables. Okay, so let's use that rule to do the rest of these. Number 2, we have j and k to the 5th power. All right, well, we're going to take our variable j, distribute that 5th power, and then take our k and distribute the 5th power. So we got j to the 5th, k to the 5th, and that's our answer. Let's do number 3. We got r and s to the 8th power, so let's separate those. We got r to the 8th power and s to the 8th power, because we just distributed that piece to both of our variables. All right, so I'm going to do the last 3 in another video just because it's taken a while, so I'll see you over there.